Jobson. I'm from Montana State University, and the title of my talk is Not Too Tall, Not Too Short, Developing Novel RHT1 Alleles in Wheat. RHT1 is the abbreviation for the reduced height genes in wheat. So what we're looking for is kind of like Goldilocks. We want wheat that's not too tall, not too short. We want the ideal just right wheat plant that's genotypically well suited for its ideal environment or end-use product. The reduced height genes became popular in the 1950s and 60s by this man, Norman Borlaug, during the Green Revolution. He introduced the semi-dwarfing alleles RHT-B1b and RHT-D1b, which you can see here on this bar graph. The agronomic impact of introducing the semi-dwarfing alleles was an increase in yield, and RHT-B1b and RHT-D1b increase yield approximately 5 to 7% compared to the tall wild type. Due to this agronomic benefit, RHT-B1b and RHT-D1b have been incorporated into the majority of modern wheat cultivars. However, despite their agronomic benefits, they're also associated with decreased emergence in arid climates, reduced protein content compared to tall wild-type plants, and also beyond RHT-B1b and RHT-D1b, there's very limited allelic diversity for semi-dwarfing genes in wheat. So the primary objective of my project has been to use non-GMO mutagenesis to develop and identify novel RHT1 alleles. So you can see in the table on the right that we were able to create and identify 16 novel mutations in the A, B, and D genomes of the RHT gene. In addition to these 16 mutations, we were able to identify 3 stop mutations, one in each genome. One in the A genome, there's the B, and there's the D. The diagram on the bottom of the slide illustrates the location of the genes within the RHT1 protein. And you can see that our mutations are spread evenly throughout the gene. The stop mutations are indicated by these yellow bars. The B stop mutation is about 3/4 through the gene, whereas the A and D stop mutations are very near the C terminus of the gene. The green boxes on this diagram represent the known binding motifs within the RHT1 protein. So we wanted to see how mutations within those known domains would impact the protein structure on a molecular level. We've been evaluating our mutations from a few different standpoints. We've crossed our mutations into adapted Montana wheat varieties so we can investigate their impact on agronomic traits. This graph is showing the impact of 6 mutations shown in the light blue bars compared to the current semi-dwarf mutations, the dark blue bars, and a tall wild type, the bright blue bar. You can see that all of our mutations decrease height slightly compared to the tall wild type. And there's one, RHT-B341, which is of interest to us because it seems to be intermediary between the current semi-dwarfs and the tall. We've also been investigating the impact of our mutations on the molecular function of the genes. We've been doing this by using yeast-2 hybrid binding assays. We found that this is a good indicator of the impact the mutations will have on plant height based on the ability of the RHT1 protein to bind to its receptor. We've also been evaluating the impact of the mutations on end-use quality. We found that the current semi-dwarfing varieties, RHT-B1b and RHT-D1b, have a measurable impact on traits such as mixing time, dose strength, and loaf volume. So we're curious to see what the impact of the novel mutations is on these traits. In conclusion, there's a need for increased allelic diversity of RHT1 in wheat. Our objective to create and identify novel mutations led to the discovery of 16 novel mutations, including 3 stop mutations in each genome. We are now testing our novel mutations for their impact on agronomic, molecular, and end-use quality traits. With that, thank you very much for listening to my rapid presentation.